For the first problem, we need to calculate the area enclosed by f and g. So the first step is to know what these begin and end points are. So I call them a0 and minus a0. Now for a general cosine wave like this, the period of the function is equal to 2 pi divided by b. And in our case, the period of f is thus equal to 2 pi divided by 2 pi, which is 1. So this is just 1, 0, since we just add one period to the x value. And then this is equal to minus 1, 0. So we are working in the interval x between minus 1 and 1. So now we know that the integral from minus 1 to 1 takes the area under a function. But in our case, we want the total area, so we will take the area is equal to the integral from minus 1 to 1 of g of x, which is the upper function, minus f of x. And this will always work if one function is above the other function on the whole domain, dx. So this is equal to the integral from minus 1 to 1 of 1 plus cosine of 3 pi x minus cosine of 2 pi x minus 1. So this gives us the integral from minus 1 to 1 of 2 plus the cosine of 3 pi x minus the cosine of 2 pi x. And now if you know how to integrate, we know that the integral of cosine is just sine. So we have to evaluate 2x, which is a 2 integrated, plus 1 over 3 pi times sine of 3 pi x minus 1 over 2 pi times sine of 2x, 2 pi x. From minus 1 to 1. But now notice that for all n in z, that the sine of n times pi is equal to 0. And we can see this very easily by drawing a circle and noticing that the sine of a multiple of pi will always end up in one of these points, and so the sine is a value on the y-axis, which then is 0. So now first we need to fill in 1 in this whole function, but the only thing that will stay is 2 times 1. And then we do minus, and then we fill in minus 1. But this will just give minus 2. Since these two will also be 0, so our answer is 2 minus minus 2, which is 4. So the area is exactly equal to 4, and we solved the problem. Let's go to the next one. For the second problem, we need to find the maximal area of this red region in this picture. Now, first of all, you can see that x must be bigger than or equal to x squared. Now, this means that let's call this f of x, which is equal to x minus x squared, which we can write as x times 1 minus x, should be greater than or equal to 0. Now, if we would graph x and f of x, then we would see that the function is 0 at x equals 0 and x equals 1. And since the term of x squared is negative, that means it is negative to plus infinity, positive between 0 and 1, and here negative again. So the only possible values for x lie in this region. So we already know that x is an element of the interval 0 to 1. Let's now express the area that we want to maximize as a function of x. We can see that a of x should be equal to 2x times x, which is this whole rectangle, minus x to the fourth. So we get 2x squared minus x to the fourth. Now, if you want to maximize this, we first have to calculate the first derivative. And that is equal to 4x minus 4x cubed. Now, to find the critical points, we have to set this first derivative to be equal to 0. And these critical points will include local minima, local maxima, or saddle points. So, the first derivative is equal to 0 if and only if 4x minus 4x cubed is equal to 0. Now we can just simply factor this into 4 times x times 1 minus x times 1 plus x. So now it follows that the critical points are x1, which is 0, x2 minus 1, and x3, which is equal to 1. So the only values that are relevant to us are the 1 and the 0. So let's now check the second derivative to see if these points are minima or maxima. The second derivative is equal to 4 minus 12x squared. So now we find that for x1 equals 0, we find that the second derivative of 0 is equal to 4 minus 0, which is 4, which is greater than 0. So this means that 0 is a local minimum. Now for x3 is equal to 1, we find that the second derivative of 1 is equal to 4 minus 12, which is minus 8, and that is smaller than 0. And this tells us that 1 is a local maximum. So we have found the value of x that maximizes the area in this interval. So now let's calculate the area. So area max is equal to 2 times 1 squared minus 1 to the power of 4, which is equal to 1. And that is our solution. The maximal red area is equal to 1. Thanks for listening, and don't forget to like and subscribe.